All right, hey guys, so we are on lesson 3.3, even and odd functions. Today we are going to recognize even and odd functions given an equation or graph. And we're going to distinguish, that means tell the difference, between even and odd functions and even degree and odd degree functions. Okay, so the graphs of some polynomial functions have special attributes, or characteristics is another word for that are determined by the value of the exponents in the polynomial. So it says graph the functions f of x and, 3x squared plus 1 and f of x equals 2x cubed plus 3x on the axes below. So we have 3x squared plus 1. This is a parabola because it's an x squared. So I know since it's positive, it's going to be facing up. And this plus 1 means that it gets shifted up 1 from the origin because parent function starts at the origin. So I'm going to shift up 1. I know it's facing up. The 3 in the front tells me the slope. So I'm going to go up 1, 2, 3 over 1 in each direction. Remember we reviewed graphing those the first week of school? Okay, so there's the first one. The second one, 2x cubed plus 3x, this is a cubic. And let's go ahead and use a T-chart to graph this one because we don't know these that well yet. And let's just be very basic. Let's just plug in a -1, a 0, and a +1. If I plug in -1 to the third is -1 times -1 times -1, which is still -1. -1 times 2 is -2. -2 plus 3 times -1, well, 3 times -1 is -3. So -2 minus 3 is -5. So when x is -1, y is -5. If I plug in a 0, 0 wipes out that, 0 wipes out that, so it's just 0, 0. Then if I plug in a +1, 2 times 1 to the third is 2, plus 3 times 1 is 3. 2 plus 3 is a +5. So when x is 1, y is +5. In cubics, we got to see a little bit the other day. They make this like sideways S-shaped thing going on. But this one, because of the 3 in the front, or not the 3, the 2 in the front, it makes it skinnier than the parent function that we saw on the previous lesson. Okay, so number 2, it says describe the symmetry of the graph of f of x equals 3x squared plus 1. So on that one, if we were to figure out how it's symmetric, it's exactly the same on the left as it is on the right. So if I were to fold it in half, it would be exactly the same on both sides. I know my picture isn't the greatest, but a parabola is symmetric that way. So that means it's symmetric about this vertical line, which is the y-axis. So we can say the graph is symmetric over the y-axis. Number 3, it says describe the symmetry of the graph of f of x equals 2x cubed plus 3x. So this one, the pink one. Now, if I were to divide that in half and fold it in half, it's not going to be the same on the left as it is on the right. It's up here on the right, it's down here on the left. But it does have a similar shape. So we have to think of it differently because that line symmetry doesn't work. Well, if I were to think of this as like rotating, it would work because I could rotate it all the way around until it lands back on itself again. So it does have rotational symmetry around the origin. So I can say the graph is symmetric around the origin. So the origin is the center of gravity, I guess you could call it. So everything in the center stays the same and then it just moves all the way around. Okay. All right. So it says the function f of x equals 3x squared plus 1 is called an even function. Notice that every power of x is an even number. There is no x to the first term. this is true for the constant term as well, since you can write a constant term as the coefficient of x to the 0 power. Symmetry over the y-axis is an attribute of all even functions. Okay, so this would be, it's even degree because it's to the squared, it's to the second power. So it's even degree. And since that 1 is technically, if we remember when the homework that we had and you had to rewrite this so that every term had an exponent, that would be 1x to the 0 power. 0 is an even number also. So it's an even degree and it's an even function. Okay. The function f of x equals 2x cubed plus 3x is an odd function. I need a different colored highlighter. It is an odd function. Notice that every power of x is an odd number. There is no x squared or constant, which would be x to the 0 power term. Symmetry around the origin is an attribute of all odd functions. Symmetry around the origin is an attribute of all odd functions. So this one is odd degree because it's to the 3rd power. So we know it's odd degree. But because the next term in it is only to the 1st power, 3 is an odd number, 1's an odd number, it's also an odd function because every single term has an odd degree. If every single term didn't have an odd degree, then it wouldn't be an odd function. It would just be odd degree because the highest degree is a 3. Okay, same with the even functions. All right, turn the page. Oh, it's the last page. How about that? This one's a short lesson. You guys will enjoy that, huh? Okay, it says, examine the sketches you made in item 14 of the previous lesson. Use symmetry to determine which graphs are even functions and which are odd functions. Explain your reasoning. Okay, so let me go grab that because I forgot to grab that. So let me grab it real quick. The lesson 3.1 and 3.2. So this is the sketches from number 14. All right, I'm about to show you my notes, and I make myself notes and pictures, so don't judge me. Okay, this is number 14, and these are the sketches. So you should also pull out your page. This is page 38 out. Okay, so let's go through, and what does it want us to do? It wants us to use symmetry to determine, whoops, you guys can't see, which graphs are even functions and which are odd functions. Explain your reasoning. Okay, so let's make a list. I'm going to color code this. We'll list the ones that are even versus the ones that are odd. Okay. So even degree means that we're to the even power. So x squared is even, negative x squared is even. Those are odd. Y to x to the 4th is even. Negative x to the 4th is even. These are odd. Okay. So to list those out, the even ones would be y equals, oops, you guys can't see again. Y equals x squared, comma, there was y equals negative x squared. There was y equals x to the 4th. And y equals negative x to the 4th. Then all the ones that were odd were all the ones that had the odd powers. X to the 3rd, negative x to the 3rd, x to the 5th, negative x to the 5th. So we have y equals x to the 3rd, y equals negative x to the 3rd, y equals x to the 5th, y equals negative x to the 5th. It says explain how an examination of the equations in item 14 of the previous lesson supports your answer to item 4. Okay, well, we know that even functions have only even powers of x, and odd functions have only odd powers of x. So let's write that. find a different color. So we can say even functions only have even powers of x, while odd functions only have odd powers of x. Okay, something important to remember, so I'm going to star those. All right, check your understanding. It says explain why the function f of x equals 4x squared plus 8x is neither even nor odd. So they're saying that this function is not even and it's not odd. Why? Why is it not even or not odd? The degree, the highest degree, is even. That's an even number, right? 2 is an even number. What is making it not an even function then? Well, what's making it not an even function is this bad boy right here, because what power is on that exponent for x? There's no exponent there, so we assume it to be a 1. And 1 is an odd number. So it's an even degree function, but it's not an even function because the next term has an odd power on it. Okay, so for an explanation for number 6, we'll write it over here. The exponents aren't all even or all odd. So in order to be an even function or an odd function, all the terms have to either all be even exponents or all be odd exponents. So this one, it's an even degree, but it's not an even function because of that 8x there, because the exponent on the x is an odd number. It's a 1. All right, number 7, it says, for a given polynomial function, as x approaches negative infinity, the graph increases without bound. And as x approaches positive infinity, the graph decreases without bound. Is it possible that this function is an even function? Well, what does this mean? So it helps when we draw ourselves a quick little sketch. It doesn't have to be perfect. We don't know much about it, except that as x approaches negative infinity means that we're going to the left of the graph. The graph increases without bound. That means it's increasing without bound means to infinity. So it's increasing to a positive infinity. And as x approaches positive infinity, that's going this way to the right, the graph decreases without bound. So now it's decreasing, so that means it's going to negative infinity. Because going up here, that would be positive infinity. Going down this way on the y would be negative infinity. Okay? Is it possible that this function is an even function? Well, remember, to be an even degree, well, if it's going to be an even function, it needs to be even degree. And to be an even degree, that means the end behaviors are the same. But the end behaviors is going up on the left and down on the right. So the end behaviors aren't the same. So no. So the answer is no, because we have to explain, because both ends are going in opposite directions. Which is an attribute. If we use those fancy words that we've seen today, it's an attribute or a characteristic of odd functions. To have m behaviors going in opposite directions, that is a signature move of an odd function. All right. So your homework will be on Google Classroom. It will not be from the book this time. It'll be from the additional practice. So you'll see a PDF of that uploaded under the assignment. Have a good one, you guys. Enjoy that it was short.